Hi, good day to you and welcome to my channel where I tutor you in science for free. The topic in this video will be waves. Before I begin, I would just like to let you know that I found a change in the syllabus from the 2023 to 2024 that skips a topic of temperature, which belongs to the previous theme. If you realize that the previous couple of videos are all about heat, temperature is just a pretty short chapter talking about calibrating a thermometer, freezing point and boiling point, using expensive material like water or mercury. So if that topic ever comes back in the syllabus, you can check it on the website. Then I'll make a video on it in the future. So for now, I'll skip it and move to the next theme of videos. Firstly being the properties of waves. And why are we studying waves? Because a lot of physical things that are happening around us, they behave in such wave-like patterns, things like sound, like light, and so on and so forth. So to better understand and describe them, we need to understand what waves are all about. So waves are a periodic motion. I believe you have been to the beach before and seen a wave, and being in a periodic motion, and I suppose you also have seen a pendulum as well, so that also behaves in a periodic motion. It also displays wave-like properties. In the gym, people do battle ropes. They are also forming waves, and the phenomenon can be described using the knowledge from these couple of videos, from these few chapters. So like in the example of the battle rope, shape of the wave travels from the force generation away, but points on the rope only travel upwards and downwards. That is perpendicular to the direction of the force. That is why such forces are called transverse waves. Or in a ripple tank, so small scale ripple tanks can be observed in a lab setting. There are those that are giant scale ones, those military grade ones that used to test a ship's seaworthiness. The dipper of a ripple tank exerts a force onto the water, causing the water to move up and down. So similarly, each point of the water moves only upwards and downwards while the force travels away perpendicularly. However, if the point of the medium travels laterally, which is parallel to the line of force, forwards and backwards, we call this a longitudinal waves. So longitudinal waves are things like for sound and ultrasound. A slinky spring, if you push and pull the slinky spring, the force travels from one end to the other end. You can see the compression is traveling, but each point of the spring is only moving left to right. And so with all these up and down movements, left and right movements, there are several vocabulary used to describe each of these points to better understand them. Firstly, crest is used to describe the top of the wave, like a crest of a hill. Trough, the bottom of a wave, like a pig's trough. Amplitude is the furthest distance from rest position traveled by the material. So amplitude goes both ways. Wavelength is any one full cycle, which means to say wavelength to wavelength or trough to trough or one crest and one trough. So what I like to see is a full 4-part division, which is up, down, up, or down, up, or up, down, down, whichever you prefer. And having this eye sensitivity to see that each wavelength has 4 different parts helps in further questions in future. And of course, SI unit of the amplitude, the wavelength is all talking about distances, so it will be in meters. So a displacement time graph will look like that, will look just like the wave itself to talk about how much distance a material has traveled, an item has traveled through the wave. And because it has a time dimension, we can see a period, T. Period is the time taken for one wave to complete. And because it's talking about time, the SI unit will be in seconds. What about the amount of complete waves produced per second? That will be called the frequency. And frequency has a formula like that. Frequency also means how many complete waves is produced in 1 second. So you take the frequency, you multiply by the wavelength, the amount of distance covered by each wave, each complete wave, you will get the speed. So you get velocity, v equals to f lambda. So this is another formula. So similarly, physics has a lot of formulas. There will be questions whereby they will give you a lot of information. You have to do extraction. You throw your formula, submit the values, and you should be able to get your answer. And we'll cover some of these examples later. Wavefront is an imaginary line that joins all the crest together or all the trough together. So I believe you have been to the beach, you have seen waves coming towards you at the shore. So a wave, they all form like a imaginary line coming towards you. That is called the wave front. And they will travel perpendicularly towards the distance it's traveling. So there's a plane wavefront, there's also a circular wavefront that you see in ripples. An item drop into a calm body of water. Circular waves will be generated and distributed outwards. Okay, let's look at some questions. So waves in a ripple tank goes through refraction. Refraction is the tilting and angling of a wave, which we'll cover more in the light chapter. So initially wavelength is 3 cm, speed of this. After refraction, the wavelength is this. So probably it has gone through a denser material or something like that. So you can see that it was taking a larger step, now it's taking a smaller step. So what's the second speed? So this, you can use basic ratio to identify it. If 3 cm gives you this, 1.5 cm will give you 0.1. Answer will be A. Wave source frequency 1000 Hertz. Okay, so this means there's 1000 wavelengths being produced in 1 second. Okay, each wavelength is 0.1 meter. How long does it take to reach 2500 meters? So same, you do extraction, there is an F, there is a lambda, you need to find V. V equals to F, now you get V velocity. So you have distance, they're asking about time. So if all of this, you can find the answer, there will be 25 seconds. Two ducks, waves moves across the pond from left to right. Okay, duck Q is at the maximum displacement from rest point, that is called the amplitude. Duck P at 0 displacement. Which row describes the movement of the ducks during the next half cycle of the wave? So this is where looking at waves with a 4-portion perspective will be very helpful. So half cycle, you remember in one wave there are 4 portions, down, down, up, up, or up, up, down, down, or whatever, down, up, up, down. Okay, so in this case, duck Q is going to move downwards, down, down, right? So duck Q only falls. P, you move 2 portions, you need to do a down and up. So it falls and then rise. Duck P falls then rise, duck Q only falls. The diagram shows part of a long stretched spring. And a longitudinal wave is traveling along the spring. So one point of the spring only moves forward and backwards, which is 1 cm apart. So it jiggles left to right 1 cm, 1 cm. Okay, so the amplitude is going to be half because the rest point is in the middle of that 1 cm. So it moves half cm to the left, then goes back to rest, half cm to the right, goes back to rest. The amplitude is going to be 0.5. Then as shown in the diagram, then wavelength is definitely going to be 12 because compression to compression is considered one wavelength. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe and share it with somebody who needs to see this. And I will catch you in the next video. Bye!